An Excel spreadsheet consists of a grid of small rectangular boxes called cells. A cell is identified using its cell address or cell reference. A cell reference is a combination of a column letter and a row number. For example, this cell is identified by the cell reference, column E, and row 4. In short, we can say that this cell has the cell reference, E4. We use this cell reference in Excel formula to do calculations. For example, we have 10 at cell reference, A4, and 15 at, C4. If I want to add 10 and 15 together and place the result in the cell having cell reference E4, then I will click on cell E4, and write my formula like this. Equal to the cell reference A4, plus the cell reference C4. Then, press Enter. This will give us an addition of the values present in cells A4 and C4. This is how we use a cell reference in the Excel formula. We can also have a range of cells identified by cell reference. Suppose, if we want to add the numbers present in the cells from A8 to D8, then we can provide the cell reference as a range of cells. Our formula will be equal to sum of, then the cell range from A8 to D8. The range in the formula is denoted as A8, D8. Then close the bracket for the function, sum. Then, press Enter. So, cell reference can denote a single cell or range of cells. This is a brief idea about what is cell reference in Excel, and how we use them. There are 3 types of cell references used in Excel. They are relative cell reference, absolute cell reference, and mixed cell reference. Let us understand them one by one with examples. Here we have quarterly sales data for products A, B, and C. Suppose we want to calculate the total sales of product A. We will write our formula as equal to sum function. Then we will select and provide the range for all quarterly sales of product A, which is cell range B5 to E5. Then, press Enter. We got the total sum for the product A. Alternatively, we can also use the keyboard shortcut to calculate the sum. Press Alt plus equal to keys. We can see that Excel smartly identifies the range of data present on the side of the cell. Now we just have to press Enter. And we get the total. Remember, till now, we have written the formula for calculating total sales of product A only. Now, we can either individually write formulas for products B and C as well and calculate their total sales. Or we can click on the tiny green box on the bottom right corner of product A's total cell and drag it down till product C. This calculates the total sales for product B as well as product C automatically, without needing to write formulas for them individually. But how did it work? When we drag the total sales results cell of product A over the results cells for products B and C, the formula for product A got relatively applied to products B and C as well. But what do I mean by relatively applied? If we go to Formulas and click on Show Formulas, we will see the formulas applied to the cells. For better demonstration, let me delete the results cells of products B and C. So, we wrote the formula only for product A. We see that the formula takes the cell range from B5 to E5. When we dragged it down to product B, we can see that the cell references in the formula are automatically updated in relation to the cell for which we wrote the formula. The cell reference B5 is updated to B6, and E5 is updated to E6. Accordingly, it takes the cell range from B6 to E6 and gives us the total sales for product B. If we further drag the formula down for product C, the cell reference gets updated accordingly and gives us the result for product C. So, in short, we wrote the formula for the product A. We dragged the formula and applied it to product B and C cells. The cell reference in the formulas for products B and C were updated in relation to the cell reference in the formula for product A. That's why it's called relative cell reference. It is the default cell reference type in Excel. In relative cell reference, as we move along the rows and columns to apply a formula, the cell references in the formula are also updated relatively. It has the syntax as column alphabet, followed by the row number. For example, A1, B5, C10, etc. Now let us look at absolute cell reference with an example. We have the total yearly sales of each product in column F. We will add them and calculate the combined yearly sales of all the products. We will select the cell. Then, press Alt, plus equal to keys. The array of numbers, above, is smartly identified by Excel. Press Enter. We have our combined yearly sales of all the products. Now our problem statement. We want to convert the quarterly sales data of each product into percentages, contributing to the total yearly sales of all products combined. To do so, we will have to take sales data of each quarter, for a product, and divide it by the combined yearly sales. We need the converted data in this table. We will start with writing the conversion formula for product A, quarter 1. The formula will be equal to. Then the cell reference, B5, that contains the data of product A's quarter 1 sales. Divided by the cell reference F8 containing the combined yearly sales data. Then, press Enter. We got product A's quarter 1 sales percentage share in the yearly sales. It looks fine. Now, we can either write the formula for each data cell for conversion. Or, as we saw in our previous example, we can drag the cell and apply the formula to the rest of the cells in the table. Let's try doing it. We will first drag it across the columns. Let's see if we get the expected results or not. Well, we ran into a problem. We are getting a divide by zero error. Let's drag across the rows and see if the formula works or not. No. We are getting errors for the rest of the cells too. This method worked in the previous example. Why is it not working here? Let's take a look at the formula for each cell, beginning with the first cell for product A quarter 1. We can see that the formula is correctly taking the quarter 1 sales data of product A, and dividing it by combined yearly sales data. So the result is right for the first cell. For the second cell, as per logic, it should take the quarter 2 data of product A, and divide it by the combined yearly sales. Let's check the formula in the second cell. Well, here is the problem. We can see that the numerator part is updated correctly, but the denominator part of the formula, which is the reference to cell containing the combined yearly sales, is also moving. That is why instead of dividing by actual data, the value in quarter 2 is getting divided by nothing and is giving a divide by zero error. And if we check the rest of the columns on the right of product A quarter 1 cell, we see that for them too, the denominator cell reference is also moving to the right or updating. If we move down across the row cells in the quarter 1 column, we see that, in the formula, the denominator cell reference is shifting down. And that's why we are getting errors for them. Now why is this happening? If we recollect, we have seen that in relative cell referencing, as we move across the cells, the cell references in the formula also get updated relatively. The syntax of relative cell reference is the column alphabet followed by the row number. In this example, in our formula, we have used relative cell referencing in the numerator as well as the denominator. We do want the numerator cell reference to get updated when the formula is applied across the cells. But, we want the denominator to be locked on the cell containing the combined yearly sales. Now, how to resolve this? Let us first take the product A row. When the formula is applied across the quarters, the numerator cell reference is getting updated as required. So using relative cell reference in the numerator is the right approach. But along with it, the denominator cell reference is also updated. We don't want the denominator to hop across the columns. We want to lock the column. We will rectify the formula in our first cell. Since the combined yearly sales is present in the cell reference F8, we will lock the column F. So, we will write a $sign before the alphabet F. Now, press Enter. Now let's apply the formula for the rest of the quarter column cells for product A, and check if it's working or not. Yes, we are getting the expected results for product A row. If we check the cells, then we can see that only the cell reference in the numerator is updating, and the cell reference for combined yearly sales in the denominator is locked. Let us apply the formula down, across all the rows. And check if it's working or not. Well, it is not working. The reason is, though we have locked the column F, the row in the cell reference is still updating from row 8th to 9th and 9th to 10th. We want the row to be locked to the 8th row. So we will modify the formula in the first cell again. Just like we locked the column F, we will lock the row to 8th by writing a $sign before the 8 in the cell reference. So now the denominator is $F, $8. Now, press Enter. We will apply the formula to the columns first. Yes, it is working across the columns. Let's see if it works across the rows or not. Yes, now it's working for all the cells. If we check the formula in each cell of the table, we can see that the numerator's relative cell reference is appropriately getting updated as the formula is being applied across the cells. And the absolute cell reference in the denominator of the formula is locked to one cell, F8, for all the cells in the table. So this is how we write and use the absolute cell reference. The syntax of absolute cell reference is column alphabet, row number. Remember that to fix the position, let it be a column or a row position, prefix it with a $sign. Now let us see what our mixed cell reference. We have the annual sales for all products combined in cell F8. And from cell F5 to F7, we have individual annual sales for products A, B, and C. We will calculate the percentage share of each product's annual sales. To do so, we will divide the total of each product by the combined annual sales. So, for product A, we will write the formula as equal to the annual total sales of product A in F5 divide by the combined annual sales in F8. Note that in our formula we have used relative cell reference. Let's press Enter and see. It gives us the proper results for the product A. But if we apply the formula for the rest of the rows below, will it work? No, it will not work. We are getting the divide by zero error just like in the previous example. Let's check the formulas by clicking on the Show Formulas option. We can see that, since we used the relative cell referencing in the formula, the cell reference in the formula is getting updated with respect to the cell where the formula is being applied. For product A we had the formula, F5 divided by F8. When we applied it to product B, the cell references in the formula were updated to F6 divided by F9. But here is the problem. We do not want F8 to update to F9. We want it locked to F8 only. And product C also has the same issue. Since our formula is applied across the rows of the same column, we only need to lock row 8 in the cell reference, F8. So as we have seen earlier, to lock a row or column, we must prefix it with a $sign. Here, we want to lock the row to the 8th row. So we will write a $sign before 8 in the F8. Now we will apply this formula to the rest of the rows below. We can see that now the cell reference in the numerator of the formula is getting updated. This is what we want because it is relative. And the denominator is locked to the row 8th of column F, in F8. Now let us toggle out from the Show Formula mode and check the results. We are getting the expected results. This was an example of mixed cell reference. In mixed cell reference, one of the parameters is locked. It may be either a row or a column. In our example, the row was locked to the 8th row. Our mixed cell reference was F$8. In this example, we would have gotten the same results if we had used absolute cell reference to lock the F8 cell reference. But it was not needed, because we applied our formula only across the rows of the same column. So there was no need to apply the lock for the column. Only locking the row sufficed the requirement. Let us quickly take an example for mixed cell reference where we will lock only the column. Here we have the same quarterly sales data for products A, B, and C. But in this example, we will calculate the total sales made in each quarter. So the quarter 1 sales of our products have a total of 375. Similarly, we will be calculating total sales for quarter 2. Quarter 3. And quarter 4. Here, in cell F8, we will calculate the combined annual sales of all the products. Now we will calculate the percentage sales for each quarter with respect to the total annual sales. For quarter 1, the formula will be equal to total of quarter 1, in cell B8, divided by the total annual sales in cell F8. First, we will demonstrate using all relative cell references. Press Enter. We got the percentage share of quarter 1. Now let us apply the formula across all the remaining quarter columns. We see that we get an error. If we check the formulas in the cells, we see that as we move across the columns, the cell reference of total sales is getting updated and moving relatively. We want the denominator cell reference, referring to total annual sales in the formula, to be locked at cell F8. Since we are applying the formula across the columns in the percentage sales row, the reference to the annual sales is also moving across the columns. So, we will lock the column. We will modify the formula in the first cell. To lock the column, we will place a $sign before the column alphabet, in cell reference F8. So, the denominator cell reference will become $F8. Press Enter. Now we will apply the formula for the rest of the quarters column. We get the expected result. If we check each cell, we can see that only the cell reference in the numerator is updating, but the cell reference in the denominator is fixed to F8. So this was an example of a mixed cell reference with a locked column. In this example too, we could have used absolute cell referencing instead of mixed. However, the formula was applied only across the columns, there was no need to lock the row for the F8 cell. Now let's see one last example, where only mixed cell reference can be used in the formula for the solution. We will convert these individual quarterly sales data into percentages with respect to the quarterly total. That means, in the quarter 1 column, we will divide this 100 by its total, 375. This 75 divided by 375. And so on. Then in the quarter 2 column, we will divide this 150 by its total, 450. This 125 by 450. And so on for the rest of the columns. We will write our formula for the first cell. Equal to this 100 in B5. Divided by this 375 in B8. Press Enter. We got the result for the first cell. This is a relative cell reference. Let us see if the formula will work or not. For product A row, it is working fine. The formula refers to the right cell references for product A. But will it work for the rest of the products? No, it won't because we have used relative cell referencing. The cell reference in the formula gets updated relatively, resulting in calculation using the wrong cell reference. Will it work if we change the cell reference to absolute? Let us check. We will put a $sign for both row and column and apply. Let us apply the formula to other columns of the product A. No, it doesn't work. We see that the denominator is now just fixed to the total of quarter 1 cell. So, for the rest of the quarters, it takes the total for quarter 1, instead of taking their corresponding totals. All calculations are wrong. Here we will need mixed cell reference. But which one? Should we lock the column or lock the row? In our calculation, we want individual sales data to be divided by the total present in row 8. We do not want the cell reference for the total to shift up or down. but we want to move across the columns of row 8. So that for quarter 1, we use this total. For quarter 2, we use this total. For quarter 3, this. And, for quarter 4, this. For the quarterly total, we are moving across the columns, but only in the row 8. Therefore we want our row to be locked but not the column. To lock the row we will put a $sign in front of row 8, in our formula. We will first apply the formula across the columns of product A. Let us check. Yes, our formula is targeting cells correctly. Now apply the formula across the rest of the products. We are getting no errors and the results are as expected. We can see that the formula is referring to all the correct cell references. If we add the percentage for each quarter column, they will add up to 100% each. So, in this example, we were able to get the desired results by only using specific mixed cell reference. Just a small tip with respect to cell references. In a formula, if we click on cell reference and press the F4 key repeatedly, then, with each key press, the cell reference will toggle between all types of cell references. Currently, this is a relative cell reference. If we press F4, it changes to the absolute cell reference. Pressing the F4 again will change it to a row-locked mixed cell reference. With the next key press, we get column-locked mixed cell reference. Press again, and we get back the relative cell reference. This shortcut key can come in handy. This was all about cell references in Excel. If you liked the information then, please like and subscribe to my channel. Thank you for your time and patience. Have a nice day.